Okay, so we're starting our agriculture unit. So this is going to be focusing on soil and food production altogether. This is about 50 slides, I think. So depending on how fast this goes, I may divide it up into two videos. Okay, so soil is actually considered a renewable resource. It's very slow renewable rate, about 1 centimeter every 15 years. But it is renewable in that it has nutrient build back into it, oxygen and water build back into it, and then minerals as well. So soil is a byproduct of the weathering and decay, and it's a thin covering over land. It doesn't happen everywhere. There's not soil everywhere, but it's made up of eroded rock. It has nutrients in it, has organic matter in it, and has the water, air, nitrogen, oxygen, as well as all the living organisms in it. It ends up being really important from an environmental standpoint because it provides, for a lot of reasons, it's a home for organisms, it provides stability, it acts in the water cycle, it gives an area, a location for decomposition and matter recycling, nutrient cycling, and then aids in climate control. So this is a diagram of soil in general. We're going to kind of look through the different parts of this, so we'll come back to this. Soil properties, thousands of different types. The textural variations, you're looking at the categories, you're looking at the size of the particles, you're looking at the porosity, so how much open space between particles, and you're looking at the permeability. So those are the three big characteristics that you look at when you're rating soil. So three different types of soil: sand, silt, and clay. Clay is the smallest, sand is the largest in size. I don't necessarily know that you would need to memorize the exact sizes, but I would be familiar with the order of them. How many zeros are we looking at here, and then looking at definitely comparing the three, which one's smallest to biggest. So you notice the porosity, permeability, all of those factors I just talked about are all dependent on which size soil you have. So the texture of soil. Is looking at the percentage by weight of different size particles of sand. So primarily the texture is, which one is the dominant size. So therefore, if it's gritty, it's primarily sand. If it's sticky, it's primarily clay. And if it's smooth like flour or something, it's primarily silt. So that looks at the different size particles of this soil. So this gives you the soil texture triangle, which soil scientists would use, which agriculture farmers will use to look at what they can and cannot grow. So this is where this becomes important and kind of interesting. So you're looking at size of the particles, composition, and you see the pure up here, pure and pure, but then you see a lot of mixtures of stuff in between. So you can actually just read this. Again, this is not something that you would be expected to memorize, but if I said that it was 50% or 60% clay and 40% silt, then we're right around in this clay thing, as opposed to 30% clay and 70% silt would be clay loam. So you see the different types. That would be how to read this chart. So you're looking at just the numbers there. Okay, best soil for plant growth is the loam as a topsoil. So the topsoil is just what's on top, very obvious. And loam is a really crumbly, really spongy soil. It has a lot of organic matter in it. It has a lot of oxygen, nutrients, water in it. The friability of soil is how easily it breaks apart. So we want, like, a loam topsoil would have a high friability, would be easily broken apart. Dark soil has a lot of organic matter in it. That makes sense. Light soil does not. The pH of soil, and again, we know pH is how much acid is in it. So the pH of soils, we know that the lower the number, the more acidic it is. And so most soils are somewhere between 4 and 8. Plants can fix nitrogen, can use nitrogen at pH of greater than 5.5. Phosphorus is available between 6 and 7. So those nutrients can be absorbed at very specific acidity. So that's why the pH is so important to the soil. In order to absorb the nutrients that the plants need, they have to have the right pH. Okay, so the shrink swell potential is just how much water can it absorb and retain. So stuff that changes a lot, like the clay. So around here we have a lot of clay. It's going to swell with water when it rains, and then it's going to dry and crack in the dry season in the summer and shrink back down and look horrible. So we are very familiar with the whole shrink swell concept. What's in soil? Nutrients are in soil. I would definitely know those nutrients. The nitrogen, phosphorus, potassium at least are the top three. The composition of soil, so 45% mineral, 5% organic matter, 25% water, 25% air. So, excuse me, moving material in soil. Infiltration is just downward movement of water. Leaching is dissolving of minerals or organic matter in the upper layers and then moved to the lower layers. And the soil type will determine what level, what degree of infiltration leaching you're going to see. So soil horizons are the different parts of the soil. If you're looking from top to bottom, what's where. So the soil profile, if you're looking at that picture, so if you have a picture of soil, okay, and here's the top with your trees and your sunshine. So here's your soil. It's the O horizon, the A horizon, the B horizon, and the C horizon. So you can see it here. That's that same graph I was talking to you about. And you can see they have it listed: O horizon, A horizon, B horizon. I don't know why that's in the way. And the C horizon. And they just each have different parts and are made up of different things. So the O horizon is the organic layer. Easy to remember. That has all the organic stuff in it. So it's the plant litter. It's all where the decay happens and decomposition happens. This is going to be really high in like rainforests and really low in deserts, which makes a lot of sense. The A horizon is just underneath the O horizon, and so this is really dark, rich, has a lot of humus in it, a lot of inorganic clay, silt, or sand. This is where the roots of the plants and the stuff ends. They don't really go much beyond that normally. We know that roots and plants help to hold soil in place and prevent erosion. And we know that the decomposition happens here as well. So it breaks down that humus and the nutrients are added. So that's where that nutrient cycling happens, is in this O horizon right here and the A horizon right here. So then the subsoil is the B horizon. That's most of the inorganic stuff. That's the broken down rock material, a lot of the minerals, a lot of the stuff that's been leached out of the top soil. And then the parent material is the fragments. This is a lot of times saturated with groundwater, and it's right above the bedrock, right above the actual solid rock. So this is the last thing. Not a lot in here. Okay, so 25,000 soil types, but we know that a lot of the crops, which is what we're concerned about right now, is grown on either grassland or cleared deciduous forest, right, that they've broken down. So you can see how, let me move this out of the way. So you can see how there's a lot bigger of an O horizon up here and an A horizon, so much more nutrient stuff in the forest than in here. So you can see how they vary between different types of climates, different types of ecosystems, different biomes. So the stuff that you're going to be able to grow is going to depend on what type of soil you have and where in the world you have. So it just kind of makes sense. So you guys can kind of flip through those pictures and take a look at stuff. Comparing, look at the number of nutrients, look at the amount of organic material in each one, and go from there. And then degradation, soil degradation. 6.4, almost 6.5 billion tons of soil is eroded every year. So huge amount, absolutely huge amount of soil erosion happening. Desertification is also a huge problem. The industrial food production is not necessarily eroding, but definitely degrading the current soil that we have. And because it's replaced so slowly, because it's such a slow renewable resource, this becomes a problem. So Erosion and degradation is just the movement of soil by wind or water or man-made components. We increase erosion with the farming, with the logging, construction, all of that stuff increases erosion. All of this is common sense, nothing new here. The types of erosion. The types of erosion are the sheet erosion, the rill erosion, and the gully erosion. So all of those will lower the fertility, and then we'll add all that eroded soil, because remember, it's got to go somewhere. So that's going to dump the nearby bodies of water, like the Gulf of Mexico, with all that sediment. So the sheet erosion, these are just a whole bunch, unfortunately a whole bunch of terminology to be familiar with. A lot of times they like to pick specific ones for answer options on the AP test or multiple choice questions. Alright, so soil erosion. It's eroding faster than it's forming on more than 1/3 of the world's planets. So you can see the stuff in the red is a serious concern, the stuff in blue is some concern, and then either non-vegetative, like desert land right here in Africa or South America, or very unstable. And I think we're going to stop there for now.